Hello, let's learn about polynomials. What is a polynomial? Well, a polynomial is a combination of powers of x. Now, I've written a definition here, and as you can see, this looks pretty ugly. There are a whole bunch of powers of x and confusing letters. So what do the letters mean? Well, these are just powers, and here's a natural number, so we're considering just whole numbers. The largest exponent here is said to be the degree of the polynomial. So we'd say this is a degree n polynomial. And the a's are really just coefficients. The coefficients are just constants in front of the powers of x. So it's a bunch of powers of x added together with some coefficients in the front. So, for example, you could have a polynomial of degree 2, which would be 3x squared plus 2x minus 1. You see it's a bunch of powers of x added together with some coefficients. We call a polynomial of degree 2 a quadratic. You don't need to have all of these coefficients. Some of them could be 0. So for example, you could have 3x squared plus 0x minus 1, and that would be just fine. So, you should be familiar with polynomials in terms of graphing them and solving equations. And I'm going to show you what polynomial skills show up on the SAT. So the first skill is called operations with polynomials. What is an operation? An operation is something like addition or subtraction or multiplication, or powers, which is really just the same thing as multiplication, or dividing. Hopefully you've learned how to do all these things in Algebra 2 and or Pre-Calculus, and these do show up on the SAT, so let's take a look. This was a problem we saw from practice test 2. You might remember it. I don't know, it was number 6. Which of the following is the sum of the two polynomials shown above? This is an easy problem because to add polynomials, essentially all you have to do is combine like terms. This one's particularly easy because of the way the polynomials are arranged in these nice little columns with the like terms right on top of each other. So when you add these together, you get 8x squared. The negative 5x and negative 2x is minus 7x. And 2 minus 6 is minus 4. So that's a really nice problem to get because this is absolutely free points. So to add or subtract polynomials, all you're doing is combining like terms. Now subtracting is a little bit more difficult because you would have to be careful enough to distribute the minus sign. All of these have to be subtracted. So if you were subtracting these, you get negative 2x squared, but then you have negative 5x plus 2x. So minus minus becomes plus. So that would be minus 3x. Oops. Sorry, I don't know what happened there. And then this would be plus 8. So the most common mistake I see is people messing up their minus signs when they're subtracting. So don't do that. All right, simple enough. Let's take a look at this one. This is a problem about multiplying polynomials. And how do you multiply polynomials? Well, you just do the distributive property. You distribute all the things and then you combine like terms. Go ahead and pause the video and give this one a try. Okay. So there are many ways to distribute, and I'll show you how I like to do it. So first of all, I'm going to do a times everything, like that. So 6a cubed plus 10a squared minus 5a. And then I'm going to multiply the negative 4 times everything. Again, you have to be real careful with the minus signs. That's a very common mistake. Negative 24a squared minus 40a plus 20. And you'll notice that the way I wrote them was to produce these nice columns, kind of like I was talking about before. That makes it easy for us to combine like terms and get 6a cubed minus 14a squared minus 45a plus 20. Let's check and see if that's one of the answer choices. And sometimes I also see students just pick the wrong answer choice. So don't do that. This looks like answer choice A. Okay. Go ahead and ask a question if you have one. All right. Here's another polynomial problem. These two examples I'm showing you were taken from Khan Academy. So you can find more practice problems like these on Khan Academy. Go ahead and pause the video and give this one a try. All right. This one is a little bit more difficult because some of the answer choices look like this or this. These are complicated answer choices. However, you can tell right away that these answer choices are wrong because here if you were to distribute this, you'd have b squared times b squared, which gives you b to the fourth. And here you'd have b times b squared, which gives you b cubed. Well, nowhere in the top are we going to get b to the fourth or b cubed. So you can tell already by inspection that the answer is either A or B. However, I do recommend distributing and doing this properly. If you were being very, very fancy, you could ignore the b squared terms and just assume that they're going to add up to 0 because answer choices A and B do not have any b squared terms. However, that is a little bit risky. That's probably what I would do. So to show what I would do 1 times b, which is b, and then I'd do 6 times negative 21, which is 126, and you get this. So I just skipped checking the b squared terms because, well, and neither a nor b had a b squared in them. Unless you're positively sure that your analysis of these two answer choices is correct, I wouldn't recommend doing this. In general, just do the most ordinary thing and distribute. However, doing things like what I did can save you time and make the test a little bit easier. Go ahead and ask questions now if you have any. Here's one more example. This one is a power of a polynomial. Now you might notice the polynomial has two letters here, u and t, and that's okay, it's still a polynomial. Go ahead and pause the video and give this one a try. Okay, this one you might have noticed is a little bit weird, but the correct answer is B. There are two ways essentially to solve this problem. One is you could do u plus t cubed like this. You can distribute either by doing these two first, or you can actually just distribute all the things times all the things. However, there is another way to solve this problem, and that is to use the binomial theorem. If you don't remember the binomial theorem, then don't worry about this. I'll just show it briefly. It's definitely not necessary for the SAT, but the binomial theorem relies on Pascal's triangle to compute powers of binomials. So Pascal's triangle is a triangle full of what we call combinations, and this row right here gives you the coefficients for a plus b cubed, which is a cubed, that is 1a cubed, plus 3a squared b, plus 3ab squared, plus b cubed. And the coefficients I got from here. The powers, you can see the powers of a decrease from 3 to 2 to 1 to a to the 0, and the powers of b increase from b to the 0 to b to the 1, b to the 2, and b to the 3. If you want to know more about the binomial theorem, feel free to look this up or ask about it later. Otherwise, you don't need this, you can just distribute. Whichever way you choose to do it, you should get u cubed plus 3u squared t plus 3ut squared plus t cubed. However, you'll notice that that isn't one of the answer choices. Don't pick something like this or this. I don't want students to pick an answer that's wrong. As you can see, answer choice B is correct, though a little bit weird. If we simply factor the middle two terms, you'll notice that the middle two terms have 3ut in common. So factoring out 3ut, you get u plus t. I don't know why you would do that. That seems weird to me. But hey, this is the SAT. So distribute properly, and then if your answer choice doesn't look like one of theirs, you can investigate, look at the answer choices. You could also distribute this to make it look a bit more normal. This thing that's factored here is very suspicious. None of the other answer choices have that. Go ahead and pause the video if you have any questions. Next, we have dividing polynomials. There are a number of ways to divide polynomials. This problem here was from one of the College Board practice tests. In Algebra 2, you learned how to divide polynomials, and you essentially learned two different ways, and I'll show you both of those. The first method is called long division. It's also sometimes just called polynomial division. So, to do long division, you want to remember how long division works with regular numbers. For example, let's say you have 748 divided by 3. So the way you would do this is you'd set it up like so. And you'd say, how many times does 3 go into 7? And the answer is 2. And then multiply. 2 times 3 is 6. And subtract. Go ahead and bring down the 4. Now you say, how many times does 3 go into 14? And the answer is 4. Now multiply. 4 times 3 is 12. And subtract. And we get 2. Bring down the 8. How many times does 3 go into 28? 9 times. Multiply. 3 times 9 is 27. And subtract. And we're left with a remainder of 1. That means the answer to the division is 249 plus 1, which is still being divided by 3. All right, if you can do long division with numbers, then you can do it with polynomials. Let's try our polynomial division problem. So the question was 5x minus 2 over x plus 3. Let's give that a try. 5x minus 2 over x plus 3. The way you can set this up is analogous to how we did this. I'll put this on the screen here. So this is x plus 3 going into 5x minus 2. First, we say how many times does x go into 5x? And this is analogous to saying what is 5x divided by x? And the answer is 5. So we put 5 here. And then the next step after we found our first number was to multiply 5 times x and get 5x. You also have to do 5 times 3. And then the next step here was to subtract. So let's subtract. And it's important to add these safety parentheses to make sure you're subtracting the 15. 5x minus 5x is 0, that's good, and negative 2 minus 15 is negative 17. And we're done with our division because x does not go into negative 17 at all, so that's the remainder. So the answer to our division problem is 5 with a remainder of negative 17, so that is minus 17, which is still being divided by x plus 3. This is long division. Let's check and see if this is one of the answer choices. And it is. This is answer choice D, so that's the correct answer. Go ahead and pause the video and ask if you have any questions about this procedure. There is another option, and the other option is to do what we call synthetic division. Synthetic division, you might remember, is a shortcut. Whoops. We can save some time by not writing our x's. You'll notice here we kind of had these columns, like the x column and the constants column. Well, we can reproduce those columns without writing the x's. So the way you set up a synthetic division problem is you just write the coefficients of the x's. So that would be 5 and minus 2. Now, synthetic division is specific to situations where you have some sort of polynomial divided by x minus r. It only works on division problems of this form. However, that is what we have here, where our r is negative 3, essentially. X minus negative 3 is x plus 3. That's what we're dividing by. So our r is negative 3. So the next step of synthetic division is to write the value of r off to the side. That is negative 3. And you bring down the first value. Bring down the 5 to the bottom. And when you get to the bottom, multiply by negative 3. 5 times negative 3 is negative 15, and that goes in this next position. And then you add these together, and you get negative 17. And now we're done. Negative 17 is the remainder, and the answer to the problem is 5. The answer to the problem is 5 with a remainder of negative 17, which is still being divided by x plus 3. And you can see that this matches this result. Let's examine a little bit more carefully what happened. So first of all, there's when you look at the restriction for synthetic division, it only works on things of this form, and the leading coefficient of x here has to be 1 in the denominator. That's important. And we used that fact when we brought down the initial 5. So notice in our long division problem here, since there's a 1 here guaranteed to fit in when we're doing synthetic division. See how we did this 5x divided by 1x? So 5 divided by 1 is going to give you 5. Imagine this wasn't a 5 but was an 8. You'd have 8 divided by 1, which would give you 8. So basically, because there's a 1 in front of the x here, whatever this coefficient is automatically going to end up here. And that's why in the first step of synthetic division, we just copied whatever coefficient is here down here. Okay, the next thing to say is that once you found your 5, you know how you multiply here and here? Well, when we do the 5 times x and we get 5x, these subtract, and we know we're going to get 0 anyway. So we can just go ahead and skip doing that. So then we have to do 5 times 3, and that goes here. But then we subtract it. So instead, what we did with synthetic division is we did 5 times negative 3. So instead of doing 5 times positive 3 and subtracting, we're doing 5 times negative 3, which is negative 15, and then adding. This negative 15 here is the same thing as this negative 15 here. So when you do negative 2 minus 15 and to get negative 17, that's what we're doing in our last column here. So what I was doing there is just kind of trying to show you the parallels between synthetic division. It's actually the same steps. It's just a nice, compact, and simple form. But it has one major restriction, that it only works on things of this form. Okay. We're going to try another example in a moment. So go ahead and ask any questions if you have them. Okay, let's try another example. However, we've done a problem like this before on our test. This was test 4, section 3, number 12. Let's take a quick look at that and remember what I said about it when we looked at it. So here I'm in test 4, section 3, number 12. This is the problem. And this problem was about dividing polynomials. That's what I said when I was recognizing what type of question it is. One idea for dividing that we looked at was factoring, because often if you can factor these, you can look for common factors and divide them that way. However, that didn't work in this problem. So how did I solve it? Well, I said this is a PAM topic, so let's save it for later. But we were able to solve it by plugging in numbers. So remember, you just pick a value for x and you plug it in and you see which of the answer choices is equivalent. This does work. So if you're choking on your division and you can't make it work, just plug in a number and it should be impossible to get it wrong. So I'd like you to try this problem again, but try it by doing the division. Notice that you cannot do synthetic division because of the denominator has a 4x plus 2. The presence of that 4 there precludes synthetic division, so you'd have to do this with long division. Go ahead and pause the video and try this problem using long division. Okay, here I've set up the division problem. So we start by saying how many times does 4x go into 4x squared? That's the same as asking what is 4x squared divided by 4x, for which the answer is 4. I'm sorry, x. Oops. Now we multiply. X times 4x gives us 4x squared, and x times 2 is plus 2x, parentheses, and subtract. 4x squared minus 4x squared is 0. 6x plus 2x is 4x. Now we say how many times does 4x go into 4x, and that of course is 1. So we put plus 1. Now we multiply. 4x times 1 is 4x, and 1 times 2 is 2. Parentheses, subtract, negative 2, and we're done because 4x does not go into negative 2. So our answer is x plus 1 with a remainder of negative 2, which is still divided by 4x plus 2. Okay, let's check and see if that's an answer choice, and you can see it is, and it matches answer choice D. Now reflecting on this, when we did it before by plugging in numbers, I picked x equals 0, which is an easy number to plug in. I think from that point, it probably took 10 or 15 seconds to solve the problem. So what do you think about doing it the intended method? Was that easier or harder? If you're doing it on a test, which way would you choose? It might surprise you that plugging in numbers could be considered the easier method, so you might even consider it as your main method for solving a problem like this. However, you can possibly run into some problems with plugging in numbers. For example, picking a number for x that makes your denominator undefined. Like here, picking x equals negative 1/2 would be a bad idea. But you should seriously consider whether or not plugging in numbers is the ideal way to go. It might save you time, it might be easy, it might be harder to mess up. It's pretty easy to mess up a minus sign when you're doing all this stuff. So go ahead and consider it for the future. There is a practice section on Khan Academy for operations with polynomials. And so I'd like you to go ahead and try a practice set of operations with polynomials right now. It's on the Khan Academy SAT list. under Passport to Advanced Math. Go ahead and do that now, and then ask questions if you have them. Good luck.